Hey,
Hello, everyone. Hi, Mr. C.
how you doing?
Hello. Hello to all of our friends, and thank you for joining us for today's Digital Making at Home live stream. I'm coming to you live from Nebraska. As always, I am here with Mr. C.
Hey, Christina. Great to see you again this week. You
How's it
good?
going?
Really
Yeah,
good.
I'm good. Yeah. How's it in
It's
Cambridge?
not too bad. It's just started to get really cold now. Like the winter gets me. Having grown up in Australia, I need that vitamin D. It like freaks me out when it gets dark. But my silver lining is that I get to sort of lock myself in the house with all my projects I haven't finished and try and get them done. So what are you up to at the moment? How's it going with you?
Well, luckily, we actually had some snow recently in Nebraska, but we've had a really warm week, and that's been really good because I'm digitally making at home with a new puppy, and
Oh,
her
awesome.
name is Cassiopeia. There she is. I know I had a photo. Yeah, she's amazing. She's really precious, and we got her on Saturday, so a lot of puppy time the last couple of days. So that's been my digital making at home experience this week.
That's
It's been a lot
awesome.
of fun.
Has she got heterochromia? Has she got different colored eyes?
Yeah, she's got a blue eye and
Oh,
a brown eye. So I felt like she's
super
pretty
cool.
pretty cool. Why she got the name Cassiopeia. It's also my favorite constellation.
Nice,
So
nice. Deep cuts.
yeah.
That's really cool.
Yeah, I'm seeing a lot of folks in the chat already. Imad from Morocco on Facebook. Alex, hello. Hello, Gobal. Thank you all so much for joining. We are broadcasting live to YouTube, Facebook, Twitter, and Twitch right now. And we'll be able to see your comments. So say hi in the chat. Let us know where you are joining from. And also make sure to hit that subscribe button on YouTube to get updates and be the first to know when we are going live. You can go to rpf.io/sub to subscribe to this channel on YouTube. Saying hello, Basim, Fred. It's great to see everybody.
Awesome. So many people from all around the world. It's really cool. And for those people who are joining us for the first time, welcome to Digital Making at Home. So what we do here is we're all about getting young people like you coding, making cool stuff, talking about the things that you're doing and sharing your work with our community. We want you to create with technology, make new things and go out and do awesome stuff together. And every week we chat with cool people. We get guests in from all around the world who are doing amazing things with technology. And we get some really young people in who are doing awesome stuff as well.
Right. I'm actually really excited about this week's theme, like because we are talking about AstroPi and just like the theme of coding in space. I mentioned I have a puppy now named Cassiopeia. I grew up just loving space and the stars, especially. Like I was obsessed with Orion's Belt, Cassiopeia, looking at constellations through my dad's telescope. It was like Star Wars was a big thing. Episodes 4, 5, and 6. We don't talk about 1, 2, and 3. 4,
No,
5,
you're
and 6. Yeah, we don't even know what those are. But yeah, like space was such a big part of my experience growing up. How about for you?
Yeah, I mean, I love space. Like, I was always sort of that kid who loved going out and camping, doing things on like the wild edge of civilization. And I think space for me, like, it's a very cliche thing to say, but it really is like the final frontier. Like, there's here and there's out there, and it's like so big. It's like if we were thinking about like Leif Erikson, who sailed across the ocean without knowing what was out there. If we sort of equate it to what he was doing, like we're in our boat and we can still see the shoreline. Like we haven't actually gone far enough out to this massive ocean that exists. And I think that's super cool. And I used to love looking at the sky as well. All the stars out there, they line up in just the right way, consistently enough that you can navigate with them, right? And I used to love doing that sort of thing.
Oh, yeah. And I remember, speaking of like just the final frontier, right? I remember when I fully grasped how big it was when there was a night where we got to watch the International Space Station and we looked at it through the telescope. And I just remember looking at it just like moving. And it was just this weird sort of like, wait, there's stuff out there that's just like so separate from us. And I was so excited when I came to the Raspberry Pi Foundation because we actually have a program where we're linked up with the International Space Station called AstroPi. And you know about AstroPi. Can you tell us a little bit about it? I'm not super familiar with it because I work with clubs. So I'd love for you to help folks learn about it.
Yeah, totally. Like I help out in the AstroPi project. So the whole thing is organized by our colleague Claire, who is super duper busy, like running around talking to the European Space Agency. Yeah, big shout out to Claire. She does loads of work to keep the project running for all the kids that can like enter and run their code in space, basically. And so I lend a hand from time to time doing some of the more technical aspects, like you can see here, astronaut Tim Peake with one of the units that are up in space there. And I actually have one here. So I've got one in my house. So I went and grabbed the one from the office. So this is the actual AstroPi. This is one of the ones that goes up into space. And so this one obviously hasn't gone to space because it's here in my hand, but this rig here is actually worth several £1,000s because it's like the way it's engineered and the amount of work that went into it, the materials that it's made of, special aluminium. So yeah,
Oh, wow. But so you said, okay, it's worth several thousand pounds. I versus like pounds, not, it's not how much it weighs, right? You wouldn't be able to lift it.
No, several thousand pounds. No, not at all. It's it's worth the engineering, the
lots of dollars,
into producing this thing, lots and lots of money. Yeah. It's a very expensive little piece of kit that houses a Raspberry Pi. So inside this you see it there. That's the one that's sort of looking out the window on the space station. So it takes photos of the Earth. And if you enter the Mission Space Lab one, which is what we'll talk to our guests about in a bit, so you can take photos of the Earth as the ISS passes over it, and you can use those to sort of run scientific experiments. We've had young people who look at the oxygenation of the oceans. They've looked at the magnetosphere over the Earth, all sorts of crazy stuff with it, all run through the little Raspberry Pis that are up in space right now.
Yeah, so there's 2 of them up there, right?
There are. Okay. There's 2 up there at the minute, and we run them concurrently to run experiments, and they do different things. And so one of them is set up pointing out at space, and the other one has its camera pointing sort of inside, but we can't keep the photos because any images they take are classified. So if you do use the camera inside the ISS on your experiments, you can't keep the pictures that you take, but you can analyze them and then get rid of them.
Oh, wow. Okay, and seeing, if we can get the image up again, there's the Raspberry Pi, but there's actually an attachment on top, the SenseHat, right?
Yeah.
Like that's that LED matrix. Can you tell us, like, what is a SenseHat for folks who may not be familiar with it?
So a hat stands for hardware attached on top. And so that's whenever you take a Raspberry Pi and you attach a little board to the tiny little GPIO pins that we have on it just there. Right? So the hat fits directly on top. And it's got all sorts of things, and it's got an array of sensors that you can use. So when you run your experiments, the idea is that you measure the environment inside the ISS. You can it has a gyroscope in it to detect whether it's moving in different axes. It has an accelerometer to detect shocks and changes in movement. There's a pressure sensor, humidity sensor, thermometer. That little array on the front has 64 RGB LEDs that can produce like 16 million colors. But obviously your eye can't distinguish those, but we can make those colors appear, in the code, it will do them. And we'll run through that a bit as well. So today we'll show everybody how to get involved and have a crack and play with a virtual SenseHat and a virtual Astro Pi at home. So you can just do it right now in the browser. Yeah,
that's super neat. Actually, I have mine here. I was just trying to take it off so we could see the separate, but we've got the Raspberry Pi, and then we have the SenseHat. So like Mr. C said, you can attach that here with the GPIO pins, and then that's what is in that container and then is on the International Space Station. We have 2 of these, which is really neat. Yeah, and so we're actually going to get to talk to some folks today about their experience with Astro Pi, correct?
That's correct, yeah. So we're going to talk to some of the previous entrants who actually had their code and their experiment they designed run in space, and we can have a chat to them about that when they get here.
Well, yeah, I think let's bring them on. I want to talk about the program. Oh, hello. So many folks. This is so cool. Hello, how are y'all doing today?
We're good. How about you?
Good. Hi, everyone.
How's it going? Where are you all joining us from at the minute? So where are you currently? Like, we love to tell everyone like how multinational we are. So where are you guys right now?
So I'm in Lausanne in Switzerland right now.
I'm in London, and Farouk.
And I'm in London as well. We're both in London.
Nice.
Okay.
Cool.
Welcome, Salim, Tim, Farouk. It's so great to have you all here. And I mean, for those of you look at a map, you'll see like I'm in the USA, we've got folks in the UK, and we've got folks in Switzerland. So I think this is the first time we've had 3 countries represented. Maybe in the past, I think we've had Ireland. So this is, we need more folks. I want to get bigger.
Awesome. But it's great to have you guys on. Thanks for coming in today. It's really nice of you to give up your time for us to have a chat about what you did. I mean, like you ran an experiment in Mission Space Lab, which is like super cool, getting to run your code in space and stuff. And Space Lab is a little more involved than Mission Zero, right? Could you explain, like, one of you guys, what Mission Space Lab is kind of about, like, and how that works?
So Mission Space Lab is like a competition that takes place throughout the whole year. And at the beginning, you have to find an experiment idea that will happen in space. So it could be anything. And so basically our idea this year was to, I'll talk about this later, but so you have to find an idea and then write a code here with a Raspberry Pi. And so you can experiment them during the year with the Raspberry Pi and see how it works and code. And so you have to code in Python. And then if your code gets selected, you get to, so your code gets sent to space, and then your code will run in space, and then you'll get your own results. And at the end of the year, you'll be able to write your own scientific report at the end. And yeah, that's pretty much it.
Amazing, man. That's really cool. And so how did you guys get involved? How did you start off and like come across Mission Space Lab and build your team and all that sort of thing?
So what happened is our math teacher, Monsieur Durantin, he sent us a private message to us three because we were good friends and we loved STEM subjects. And he thought that we would enjoy a lot this because, well, we loved space, we loved physics, we loved coding, and this put everything together. So it was like perfect for us three. So yeah.
That's awesome, man. And what was it you were trying to investigate? What was your scientific hypothesis?
So basically our idea was so we knew the ISS traveled in an orbit around the Earth, but our idea was to, kind of see how it travels and does it sometimes maneuver itself to sometimes what we wondered is does it sometimes maneuver itself, and so what we did is basically measure every second the acceleration and the orientation of the ISS, and we kind of then built graphs to see how it moves in space.
That's awesome, because it has a decaying orbit, doesn't it, the ISS? It's constantly falling. Effectively, it's always falling towards the Earth, and they have to correct that every so often to make sure it doesn't crash, yeah? And so did you guys find that sort of interesting information when you ran your experiment? How did it go to did you get the readings you were looking for and things like that?
So
Go ahead.
Something interesting we realized is that the belly of the ISS is always oriented towards the Earth, and that's something we had no idea about. And something else we realized is the acceleration of the ISS isn't always constant, and at some points, what will maneuver itself or kind of, as you said, just change its orientation or just do something to correct its trajectory. So yeah.
That's
wow.
awesome.
Farouk, what was it like for you to run Code in Space?
Well, it was really exciting because at the beginning when we get the email from our teacher, we didn't think we would have we would actually be selected to be able to send our code into space, because I think there was 4,700 something teams. So we were really happy when we got the news that our code was selected to first go to space, and then to get told that we were one of the 11 winning teams. We were really psyched about it. We were together when we got announced that, and it was a whole good experience overall. I think it was the thing that made it work, I think, more than it would have with some other people, was the fact that we've known each other for a very long time. Me and Selim have been going to the same school since we were 11, and Timothy came. And Timothy came when he was, I think, 13 or 14. So we did know each other very well. I live 10 minutes across from Timothy. I can walk to his house. The fact that we're so close together was really helpful.
And have you always worked on projects like that together? Have you done other stuff outside of Space Lab as projects collaboratively?
I see Timothy nodding. Yeah.
For our French baccalaureate, which is the equivalent of the A-levels, we had research projects, for example, and we did it on void travel. So we talked about the Hyperloop and the journey to Mars, and we did that together as well.
Very cool. And so, Timothy, have you got any strategies for working together as a team and making sure that collaborative working works?
Well, we worked together. We worked together on everything. We didn't really hand out tasks. We every Friday we had a session where we were 2 hours together, and we said what we did during the week, and also the teacher was here to help us if we had any problems and stuff like that. And also, though, yes, of course, there was constant communication because we were next to each other, as Farouk said. There were constant communication during the whole week of, if someone needed help from one another. For example, Farouk helped me with the coding. He gave me some site to find out how I could code specific things, we all helped each other, and it was very, very, very nice experience. We loved it.
That's awesome. Have you got any tips to continue that? Have you got any tips for other young people who are going to work together to make sure that stays positive? Because I know sometimes working in teams, especially when you're working so tightly, it can be hard to sort of maintain your positivity sometimes. Have you got any tips on that?
Tips. I think one of the most important thing would be that people you get along outside of work is important, because the fact that we were able to work together, but then also for example, we could go eat outside, go to a party together. We can hang out with each other, which is something that the fact that the person you're working with is a friend rather than just a colleague, I think is important as well.
Definitely, yeah, man.
Yes.
I hear that. That's
Yeah, I
really
love
cool.
that. I think that's super important. And I think it's something that I really appreciate when, especially now, honestly, right? Like a lot of folks like who you work with is also can be your social circles,
Yeah.
excuse me, in some place. So it's having folks who are your friends and who you can be honest with about how it's going, where we're all remote now, right? And I know some, especially in the UK, folks are navigating the lockdown. So just, having friends that you can connect with and talk about work stuff, but also to have a fun with. Like that, I think that's likely what led to such a successful project. And congratulations on being one of the winning teams. That's such a cool thing to have done together.
Absolutely, yeah. And so after you guys won, like Salim, you went to see Tim Peake, like give a conference, and you had a live stream with an astronaut. Like, what was that like?
Well, it felt like almost like intimidating, like we talked to him about our own project, and it felt, unreal when I was talking to him and we explained to him everything we did. And it just felt incredible because after everything he has done and like the person he is, just talking to him and explaining what we did was amazing. And then he did talk to us a bit about his experience as an astronaut too. And something that was also like really, really cool is that as a prize for winning, we also had a small webinar with another astronaut who also talked to us about many of his experiences in space, and that was very interesting. So yeah.
Super cool. Yeah, I understand astronauts are really chill guys. Like, I've heard that's the #1 criteria for being an astronaut is that you have to be pretty cool. Because if you're stuck in a metal box in the middle of space with people for like 6 months at a time, like, you want to be able to get along, and like sort of put your drama aside.
When you apply, it's like, are you cool?
Yeah, definitely. You have to tick that cool guy box. Yeah,
I have folks wondering, I have Alex on Facebook is wondering, do you all have any other projects right now that you're working on at home? Like any personal projects?
Personal project. Well,
but I also know that you both are all in school, right? Too.
Yeah, not at school.
So,
we just all started uni.
Okay.
So right now, I think we're just all focusing on our uni work for the moment. Just trying to make sure that we're doing our work on time, especially with the fact that we're having online uni. So it's something we're not like. Even the universities are not used to it. So we're trying to stay just as much as we can working on our uni stuff for the moment. I don't think we have big project like this one for the moment.
I do.
Oh, you do?
Oh, is it?
So basically so I love this. I mean, even though like everything's online, so basically I'm doing computer science in my university, and we all have in computer science here 2 projects this first semester. And even though there was like the lockdown and all lessons were online, they still managed to, do these projects. And so I just finished the first one, which was about cryptography, which was really interesting. And now I just started the second one, which is about making a video game. So I'm really happy with that. Yeah.
That's cool.
Yeah, same thing for me. I don't have, it's not uni, but like on the side, I love artificial intelligence, machine learning, genetic algorithms, and all of that, neural networks. And I always I code and I try and make stuff by myself on the side because I love that. Like, it's a hobby, and I would love to do that in the future.
Super cool. And Farouk, what sort of stuff are you doing at university, man? Like, what are you working on your coursework?
Right now, I've been working on a CBG plant in Uganda. We're doing a lot of different projects at the same time, and the one that is taking me the most of my time for the moment, I think, is the Uganda plant. We basically have to kind of choose how to choose the site location and the types of dam to use to build a hospital in the capital city, and where we should put it, how we should build it, the materials to use, next to which river, where to get the power from, how much power is needed, and stuff like that. But basically, I'm studying mechanical engineering at UCO, so we're just having a lot of different subjects like that to work on. That's
cool. That's so cool. And thanks for coming in today, guys. It's been really inspiring to have a chat with you about Space Lab and running code in space and all that awesome stuff. So thank you very much for offering up time today. Really cool.
Yeah, well,
thank you.
Thank you very much. Thank you very much for having us.
All right.
Thank you.
Bye.
Bye.
See you later.
Bye.
Bye.
Awesome. How cool are those guys, right?
That was really neat. I
Yeah.
was processing as they were talking. I was like, I've never talked to an astronaut before. That's
Yeah,
such a cool experience to have. Like, that's a really unique and special thing that like they'll get to share with folks. And it sounds like it also just inspired them, like in the work that they're doing. So that was really interesting and just really, really awesome to hear. I don't know what I would have done had I been a kid that like, because AstroPi didn't exist when I was in school. So to be able to code something, let alone win and like send it to space is pretty amazing. But yeah, we actually have a coding project. We have a little bit of time left where we can show folks how they can play with the AstroPi, the actual like what it looks like and how they can do some code. So yeah, we got it up.
So what I've got here, like you can see it now on the screen. So this is the Trinket web app basically, and you can write Python code on the left here. You can see we've got a mock-up of the AstroPi, so it looks like the legit one here. It's just like a virtual version of it, and you can run your code on the AstroPi here and can control the environments using these sliders and things to see if your code works. So if you go to trinket.io/mission-0, you can load up the SenseHat emulator or the AstroPi emulator, and you'll be looking at exactly what I'm looking. And so to enter Mission 0, which is sort of the entry-level project version of AstroPi, you only have to write a very simple script, and it should run for less than 30 seconds. So the only criteria really to run your code are that it measures the humidity, that it accesses the LED array, and that it all takes less than 30 seconds. So if you can do those three things with your code, you can run your code in space, and we'll send you back a certificate as long as you're part of the ISS member states. But we can talk about that in a little bit. So should we do
the ESA member states, right? The ESA member states.
Absolutely. Sorry, yeah, not the ISS member states.
I was like, oh, there's a member? How could I join?
ESA member states, thank you. Yeah. So once you've got your empty script here, you'll see that it's given us 3 lines of text already, Christina, and they're the default ones that come in as soon as you boot up the AstroPi emulator. These are the 3 lines of code you'll get, and they just set up your script for you. So no matter what you do in Python, you do these bits first. So you can see at the top, we've got from SenseHat, import SenseHat. What I'm doing here is I'm telling the AstroPi that I'm about to use this library called SenseHat, this module called SenseHat, and if you don't go and get that and import it into this script, you won't understand what I'm talking about. So if I asked you to go to the storeroom in the workshop and get me a reciprocating dingle arm made of prefamulated amulite, you'd have no idea what I was talking about, right?
No.
Right. But if I gave you a book that had a definition of what that was and a picture of where to get it and all those sorts of things, you could then work it out. And that's the same.
Yeah, I love that. Yeah, that's a really neat analogy. Right? And so, for folks at home, make sure we've just put the link in the chat so you can join us and do some coding if you'd like.
Absolutely. And then so the next part is like the fancy term is instantiating an object, but what I'm really doing is I'm setting up so that every time I say the word sense in my code, I'm bringing in the next part. So sense really means this, and that means I'm accessing my SenseHat library, and I'm going to issue commands through it. And the next part is sense.setRotation. So that's a set command, and what that does is it takes my LED array, those light bulbs, and it turns it 270 degrees because the AstroPi is actually side mounted inside the box. So we take care of all that for you. So no matter what code you put in here, your writing will come up the right way so you can read it. It won't be sideways. Does that all make sense?
Yeah.
Cool. So then the next part we've got to do is give it some instructions. So I've got all the first parts that sort of set my code up. The next part I really want to have it do is, the first thing I need to do is check the humidity for me. And so what I want to do is I'm going to make an empty jar or a variable called humid. So I'm going to say humid, that's my variable. And then I'm going to tell that what I want it to do is to sense.humidity, right? And so that then is going to go away and use my SenseHat library to detect the humidity and store it in my empty jar that I've created called humid, or my variable. And so whenever I want that, I can go and check it. I can have my program, look, go check the humid jar, and it will go and have a look and tell me what that value is when I want it. And that value can change and do whatever. And when I want it, I check at the time I need it, and it brings it to me.
Right. Go ahead. Right. Well, yeah, exactly. I think that's really neat because I know folks use, especially like the humidity sensor. We have folks in our community who use the Raspberry Pi and the SenseHat in projects with greenhouses, and we've talked about that before. And then with here, we'll be able to pull the humidity and modify it with those. What are those called at the top? Just the changing the humidity at the top there.
Absolutely, the sliders. Yeah,
sliders. I was like, what is the word slider?
Yeah. I hate it when that happens. The word's just on the tip of your tongue, right? And you can't remember what it is. There's a specific term for that. And it's really ironic because it's on the tip of my tongue and I can't remember what the term for having the thing on the tip of the tongue is. Okay, so what I'm going to do now is I want to set up some colors because in my code, I'm going to have it go red if it's too humid and green if it's not, just because that's a nice thing that, I want to do. So I'm going to have my writing go red. So I'm going to make a couple more variables. I'm going to say, when I say red, I mean this string of numbers, right? I mean 25500, which is the RGB code for red. And I'll
okay, so 255 is the R, 0 is the G, B is 0. So we're doing full number of red. And for those folks at home, if you're coding it, you can do 0 to 255 for your colors.
That's right. Anything over 255 with the SenseHat library and your code won't work. It would tell you that it doesn't understand the numbers, but we can use it here. All right. And then so once I've got it sensing my humidity and polling that into humid and saving it in there, then I can tell it to make a loop for me. So while true, what I say while, I mean as long as a condition is met, and true means yep, or 1 equals 1. So as long as 1 equals 1, do this thing, which means forever. So just keep doing this thing. And I'm going to say if humid is greater than or equal to, let's say 40, then I want you to show me a message. Okay, and so these things here sense, oops, see, it's showing me I've got a typo, I've got to fix that.
I love that about Trinket. It's so helpful.
So handy, right? So
yeah.
handy. But the thing is, so all of these sense.showMessage, sense.humidity, all of these things are pre-built into the SenseHat library, and you can get those instructions across at rpf.io/mission-0. You'll see that there's some instructions there for teachers and things. If you want to sign up your class or your code club, you can do that at rpf.io. Where are we? So I'm going to have it say that message, and
I was seeing some folks that, hi, oh, we've got Ali on Facebook. Hello from Iraq. And I saw earlier, Aisha, I hope I'm pronouncing it correctly, from Tunisia. Thanks for joining. And let us know if you have any questions about AstroPi or about coding in Python here. Mr. C is a great person to ask those questions, so we are happy to answer those. Oh, seeing from Alex, me encanta. I know it's super cool, right? Me encanta. He loves it. Alex loves what we're doing. That's great.
Awesome. Cool. And so that there, so you can see the code I've got there. So I've got a loop here, while true. If my humidity level is above or equal to 40, then I want you to show me the message that says it's humid in the text color that I set previously as red. So you can see here I've got red, and that should go up here and find, okay, when you say red, you mean set the color to be that.
Right, okay.
Okay, so like I was saying before, I can pull red anytime I want, and I can pull humid here. I can pull that anytime I want, and I could say instead of if humid is greater than or equal to 40, I could have it if humid ever drops below a certain thing, or if humid exactly equals a thing. Anytime I want that variable, I can use it for whatever I want now. That's always going to be pulled in my code, okay? So we want...
And it's important to mention for folks, when you're naming variables, name them something that's practical. When I first was learning code, I would get like really excited and be like, unicorn star. And then I was like, I don't know what this is. And it was for humidity. So make sure to name it something practical. So, because you're going to be using it, like you said, and you're going to be referring to it over and over again.
Exactly. So let's see. So what I can do now is I can try and run my code and see if I get any errors. So let's see what it says.
While you're doing that, I'm going to say hi. Aisha is saying that they're a computer science teacher and they teach Python. Oh, great, Aisha, maybe you could teach us some stuff. Let us know how you're using Python in your classroom. That's really cool. Have you tried using Trinket? Have you tried using Raspberry Pi or the emulator? I'd love to know. Okay, is it working? Oh, it looks like it is.
Sort of is, because it's only showing humidity. So I've got to pop in a method. Okay. And then let's see now.
Oh, that's my favorite. Debugging. This is the best part.
Something like that. Okay, so.
And this is why Trinket is such a great tool. If you're also an educator who's coding in Python, the Trinket's really great. Like it helps you to correct, like it gives you the corrections.
Okay,
Let's see. Got to correct line 4. There we go.
Okay, so let's see. Cool. And we got it debugged. So it's checking. So I've got my humidity slider here. It's at 14. So I can pop it up to higher than 40. And it should, as it comes around now, it should change to humid and tell me that it's too humid. No, it's not. Why not? What's it not doing?
Oh, and hearing, Ali is telling you should print hello from Iraq on your SenseHat. And then also saying like he uses Trinket with his code club members. That's super cool. All right. And I'm seeing some questions while you're debugging there. Aisha's are asking on Facebook about like a website about Python games and projects. Aisha, you can go to, and I also hope I'm pronouncing your name correctly, you can go to projects.raspberrypi.org, and you can actually filter projects by software, hardware. So you could filter them by Python, and you'd be able to see a bunch of projects that we have there. We have over 200 projects in our library, and you can check those out for Python projects. And we're getting some suggestions in the chat. Someone's suggesting using sleep in the loop. Thank you so much. Is that Pascal?
Yeah, we can totally add a sleep in the loop. So the sleep is already kind of inherent in the sense that the message takes a little time to scroll through. So that's cool. We can totally do it. We have to put a sleep import at the top. So we'd have to bring in again another module. So time is in a different module. We have to come pull that in.
Right. So you have to add that in.
And then we should be able to get it.
This is exciting. Thanks for suggesting, Pascal.
Cool.
All right, we're running it. He's got a shout out from Sinbad calling you Mr. Code Captain. Mr. C's, your other name is Mr. Code Captain. Nice.
All right, let's see if we can get it to you.
All right. Moment of truth. I always cross my fingers.
Where is my console? There we go. So I was printing the console every time it runs a loop. Down here, you can see it printing out here. It's printing testing every time it runs my loop. Cool. So I can tell that it's waiting. And then, yeah, I can set my humidity up to way higher. It will run that loop. It will wait for a second, and then it will check again. It should go to red. Cool. Okay. And so I could submit that code now, okay? So
nice, you did it.
Right. Although if you see that my code takes a little too long to run, but that's because it's running forever, right? So if I got rid of my while true loop and ran it once and had it display and then run my code, that would be fine, and I could submit that. So if you're an educator, you need a classroom code to submit for Mission Zero, but that's very easy to do. If you go to rpf.io/mission-0, you can sign up as an educator and you'll get that code, and then you can sign up as many young people as you would like with your code, whether they're part of your class, your code club, your dojo, whatever that is, your social group, then they can all run that sort of code.
Oh, wow. That was great. We had folks from all over the world chatting with us about AstroPi, then getting to code on Trinket. This was a really fun stream. And thank you so much to all of you who joined from home. Aisha, Gobal, Ali, Pascal. It was so great. I saw Kevin and Anna earlier. Thank you all so much for joining us. Really appreciate it.
Absolutely. It was really cool. So we've got another live stream next week, everybody. Same time, same place. Remember to subscribe on our YouTube channel so that you can get those updates to know when that happens. And when we go live with our other content and things like that, you'll get all those pings. So thank you for being here, and we'll catch you next week. We're doing more cool stuff.
Yes. See you all next week. Stay safe and healthy, all.